Hey guys, so I am going to be sharing some of the solutions videos in classroom for certain things. We did go over the kinematics in class and we didn't seem to have any issues. If you do, please go ahead and send me an email and we can run through some of them. I want you to be able to see how we're working out some of these speed and velocity equations though, because as we noticed on B-Day class, it got a little more complicated and we really have to think through some of them. So I want to walk you through the thinking. I will do my best to timestamp when each problem starts. So whatever you have a question on, you can check. And then I will post the solutions, but unless you know how I got to the solution, it's not really going to help. So let's go through all of our speed and velocity equation or questions together. I'm just going to bring up my camera. So summarizing the difference between speed and velocity. So speed has a magnitude, meaning that there is a number that is associated with it. So it's a scalar and there's no direction. Whereas velocity has a magnitude, but it's a vector, which means that we have a direction associated with it. I-O-N. So that one's pretty straightforward, but it's really good to make sure that you know the difference between those two. All right, problem number 2. What you're going to see as I go through problems, I actually like to highlight the important information because word problems have a lot of words on them and not all of them are important. So texting and driving is a dangerous act and is illegal in many areas. Suppose a driver takes 3.5 seconds to send a text, traveling at 95 kilometers per hour. How far in meters did the vehicle travel while the driver was distracted? So there's a couple things that we need to notice here first. So my change in time is 3.5 seconds. And traveling is another word for how fast we're moving, which is either speed or velocity, but we aren't given a direction. We are just given a kilometers per hour, so we're going to call it speed. So our speed is 95 kilometers per hour. And then what they're asking for is our actual distance in meters that we traveled, but we don't know what this is. So this is what we're looking for right here. Now, a couple things that we need to notice is that our units really don't match up here. So we have seconds and hours, and we have kilometers and meters. But because we're solving for meters, when we do that, then our speed would be in meters per second, because our two options are our kilometers per hour or meters per second. So we need to make sure that our V that we put over here is also using the same units. So we have to convert 95 kilometers per hour into meters per second. So I have my 95 kilometers in 1 hour. I'm going to take care of my kilometers first by canceling them out into meters. So I have 1,000 meters in 1 kilometer. And I don't believe this is on your equation sheet, but I will have references in the room. And if you are remote, I will get you a printed reference for all of your different prefixes. They're really good to know, but I don't believe that I need to test you over having that knowledge. I'd rather make sure you know how to use all the information. So that gets me to my meters, and now I need to get to meters over seconds. So I have my 1 hour, and in 1 hour I can go to minutes to seconds, or I know that it's going to be 3,600 seconds and cut down a little bit of time there. So I'm going to, first I cancel out those guys. I'm going to multiply my numbers straight across. And then divide by my 3,600 on the bottom. So I am moving at 26.389 meters per second. We talked about in class, and I want to reiterate, I am not going to be super picky on significant figures. It is something that in college is important to know, and there are some classes that are going to require it. But I can say, as having been a practicing engineer, sig figs aren't really used in the real world. Do you need to know them to be able to get to the real world? Yes. But I have to review them every time I do it. So I'm not going to be super picky. I will always tell you at some point what number for decimal I want you to round to. This one is pretty easy because I just wanted to get an 8 in there, and then I rounded my next one up. So this is my new speed that my car is traveling at. So I think there's a spider in my room. Anyway, so my speed is now 26.389 meters per second. So I've got 26.389 meters per second equals my distance over my change in time. And I will always write out the equation with all of my variables in it first. That is always going to get you at least partial credit on my test and my quizzes. If you do not write this and you skip all of your steps straight to your answer, you could miss 5 to 10 points per problem if your answer is incorrect. And as of right now, you will not necessarily be given or have points taken off if you do not include this specifically. But if it becomes a problem, then we'll have to. So please, please, please just always write down your starting equation. It's also going to help you remember it. So my 26.389 equals D over 3.5. So I'm going to multiply my 3.5 over. This is not mathematically a thing, but to me, it tells me that I'm distributing it. So I'm going to keep this number in my calculator just for accuracy and have 3.5. So I end up with my distance that I traveled being 92.361 meters. And again, on that one, I just went until I had my repeating decimal. So, question 3. I want to apologize to my B-Day kids in class. I did this one incorrectly in class. You are not going to be counted off for it. You will also probably not see this question on a quiz, which you will be going through tomorrow. So, just a heads up. So, at an altitude of 6,679 kilometers, so I'm going to, above the center of the Earth, International Space Station can complete one orbit in 1.5 hours. We want to determine the average speed of the International Space Station. And then they want us to explain why we need to calculate speed and not velocity. So I like to always highlight just explain so that I make sure that I go back and do that second part and get those points. So we did this a little wrong. I started out, I wanted to try to think this through. So I'm a very visual person. I have the Earth here. Here's my International Space Station satellite. That's more of a satellite looking thing. Anyway, so I know that above the center of the Earth, it is 6,679 kilometers. But I'm looking at its orbit, which means its path all the way around the Earth in that really cool circle, right back to where it started. It can do that in 1.5 hours, but I need to know what that total path is. What's going to be really nice is you are going to have the ability to look up any extra equations that you need. I am not going to put one like this on your quiz, so you shouldn't need this. But we have to calculate the circumference of our path around the Earth. And so that is going to be 2 pi r is going to equal our actual distance that we're looking at. 2 pi r, not pi r squared like I said in class. Sorry, guys. It's pregnancy brain, and that is a very real thing. And just letting you know, if you need to correct me throughout the year, I don't take offense to it. Sometimes brains are just haywire, especially that early in the morning. So I'm going to fill in my numbers, 2 pi and then 6,679 to get my distance. So 2 pi 6679. So I get 41,965 point. In this case, I'm just going to round up to 4 kilometers. So that's my distance that I can use. So now I have my distance as my 41965.4. I like to rewrite things so that I kind of start the next equation fresh. My change in time for it to do one orbit was 1.5 hours. And I know that my velocity or my speed can either be in meters per second or kilometers per hour. So I'm all set up here. So I want to know what the speed is. And it tells us average speed. So I know that this is actually what I'm going for. So my speed equals d over delta t. And I guess one technical aspect of this is it wants average speed, but the International Space Station, even though it might deviate in what it's doing, we have a total time here and a total distance. So we already know over that entire distance that we're going to be calculating the average speed. So I'm going to plug in my 41965.4 over 1.5 to not get 95 million kilometers per hour like I did earlier, but I get 27,976 kilometers per hour. 0.9. Let's give that the 0.9 because it's pretty close. So that is the average speed. Now, why am I calculating speed and not velocity? If I calculated velocity, then this would not be distance. It would be my displacement. Now, the International Space Station is kind of like the Flash that we talked about. So you can blink a really, really long blink for an hour and a half, and it would be in the exact same spot. So its displacement from where it starts to where it finishes over that hour and a half is technically zero. Is it moving faster than zero? Yes. But because our direction is that it hasn't moved at all, we want to calculate speed in this instance. Now on to question 4. So a train travels 6.1 meters per second east. Because it's given us a direction, that's a vector. So we already have an idea of what we're going to be calculating. And the train's destination is 134 kilometers east. How long until it arrives? Train travels at 6.1 meters per second east. And because it's traveling and it gives us meters per second, we know that it is going to be our v. But because we have a direction, which is east, it's actually our vector for velocity. So the train's destination, which means how far it goes from start to finish, it's 134 kilometers east. And we already know that we need a direction on it for it to be a vector. And we're going to be looking for the change in time or how long it takes for it to get there. Now we have a bit of an issue here because we have our velocity in meters per second and our displacement is in kilometers. So I'm just going to go ahead and change that over to meters. And if you can do this in your head, feel free. This part I'm not super concerned about because I'll be able to tell if you did it wrong. So 134,000 meters. Now when I come down here, I have my equation. So my velocity is my displacement over my change in time. And you can either rearrange this with the variables in it, or you can put the numbers in. It's going to be the exact same math either way. So I'm just going to go ahead and put my numbers in. So 6.1 equals my 134,000 meters over my change in time. If you wanted to, once you've written this original equation, you don't have to write the deltas anymore. I'm totally okay with that. So then I would multiply my delta T over 6.1 T is 134,000. So I divide by my 6.1, divide by 6.1. So I have 134,000 divided by 6.1, and I get 21,967.2. And it looks like a really big number, but remember it's in seconds. So if you want to make sure that that looks right, you can divide it by your 3,600 seconds within an hour. It'll take about 6 hours to get there. So you can do it either way. The seconds looks wrong, but it doesn't ask us to do it in hours or in seconds. So 6.1 hours would be correct, or 21,967.2 seconds. Normally we wouldn't talk in seconds, so converting it to hours is friendlier. All right, so I did number 5 in the video over speed and velocity, so I'm going to skip over that, and we're going to move to question 6. What is the velocity of a jet that travels 785 meters west in 2.39 seconds? So we're looking for velocity, and it travels at 785 meters west, and the time is 2.39 seconds. So I know that what I'm getting is going to be a vector, and traveling Okay, so for question 6, when we're looking for the velocity of a jet that travels 785 meters west in 2.39 seconds. So I'm looking for my velocity. My displacement, it had traveled 785 meters west, and the time was 2.39 seconds. So we already have meters and seconds, so that's really nice. So we can just go ahead and write our equation and then plug in. 785 over 2.39. This one is nice and straightforward. Yay, yes. So 785 divided by 2.39. So our velocity is 328.45, and our units are meters per second. And then we want to make sure we put that we are traveling west. There you go. All right, and then question 7, complete the table solving for the missing values. So we're going to have to do the math on these here. So I have an extra sheet of paper. I'll just go back to that and use it as scrap paper. So my first one, for all my equations, I'm using my velocity vector equation. And so if I know my velocity is 85, I'm looking for delta D, and my delta T is 7.5 hours. My units match up. Thank you. That's much nicer. So I can multiply my 7.5 over and do 85 times 7.5 and get that my displacement for this box is 637.5 kilometers. And because it's a vector, I want to make sure I include east because that's the direction that my velocity told me we are going. For the second one, I have my displacement is 254.5, and my time is 4.3. Again, my units match up to where I need them to be, so I can just do the math on that. And I get 50, I should write down here, 59.19. And I'm going to do meters per second And then my direction for my velocity is south. If you forget to add your direction, you do miss points for it. So make sure those are included. Okay. And then my last one, I have 22.1 equals my 4,530 divided by delta t. My units match, so I'll be okay. Now I can multiply my delta t over and then divide by my 22.1. And I get 204.98 seconds. So there you go. If you have any questions on how I did any of those, please let me know.